Hello everyone and welcome back to my channel. In this video, we're going to talk about resistors in parallel, Kirchhoff's current law, and current divided theorem. But before we start, if you are new to my channel, please subscribe and hit the like and notification bell so you won't miss any of my upcoming videos. Let's begin. The circuit shown is a parallel circuit with n number of resistors connected to a voltage source with a voltage E. For n number of resistors in parallel circuit, the equivalent resistance RT is equal to 1 over 1 divided by R1 plus 1 divided by R2 and so on up to 1 divided by Rn. The voltage across each of the resistances is constant and is equal to the source voltage E. And also, the total current is the sum of the currents through each resistor. For example, in the circuit shown, we have three resistances R1, which is 7 ohms, R2, which is 5 ohms, and R3, which is 12 ohms, that are connected in parallel and supplied by a battery, which is 24 volts. So we are asked to find the total resistance RT and the total current IT, I1, I2, and I3, which are the currents in each of the resistors respectively. So, in order to find the equivalent resistance RT, we're going to use the formula above. So, therefore, RT will be equal to 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. When we substitute the values to the formula, our RT will be equal to RT equal to 1 over 1 divided by 7 ohms plus 1 divided by 5 ohms plus 1 divided by 12 ohms. So therefore our RT will be equal to 2.35 ohms. Okay, that will be the value of our equivalent resistance RT. And then we can find the total current IT by using Ohm's law. So IT will be equal to voltage, which is 24 volts. So E divided by RT. So therefore our IT will be equal to 24 volts divided by 2.35 ohms. So our IT will be equal to 10.21 amperes. Okay. So that will be our total current. So now, in order to find the individual currents through each resistors, we can also find the individual currents by using Ohm's law. So let's say for I1 will be equal to E divided by R1, which is equal to 24 volts divided by R1, which is 7 ohms. Okay, therefore our I1 will be equal to 3.43 amperes. Okay, so we use the same voltage because, as we said, in parallel circuits, the voltage across each resistor is equal to the source voltage. So for I2, we will do the same. I2 will be equal to E divided by R2 will be, which is equal to 24 volts divided by 5 ohms. So therefore our I2 will be equal to 4.8 ohms, amperes rather. Okay, 4.8 amperes. And then finally for our I3, I3 will be equal to E divided by R3, which is equal to 24 volts divided by 12 ohms. So I3 will be equal to 2 amperes. Okay, and now for Kirchhoff's current law. Kirchhoff's current law states that the sum of the current entering a node is equal to the sum of the currents leaving a node. So therefore, sigma I in is equal to sigma I out. Okay, so for example, calculate the currents I3, I4, and I5 in the circuit below. Okay, so we're asked to find the currents I3 here, and I4, I5, and I7. So we should include I7 in there. So solution is, if we apply KCL or Kirchhoff's current law at node A, we can see that the currents entering node A is 48 amperes. And the currents leaving node A rather, is 22 amperes for I2 and I3. So therefore, applying KCL at node A, so I1, which is the current entering, I1 is equal to the sum of the currents leaving, which is I2 plus I3. Okay, .48 amperes is equal to I2, which is 22 amperes, plus I3. Okay, so transposing 22 amperes to the other side, so therefore I3 will be equal to 48 amperes minus 22 amperes. I3 will be 6 amperes. Okay, so the value of I3 there is 26 amperes. So if we apply KCL at node C, we can see that the currents entering node C is I3, and the currents leaving node C are I4 and I6. So if you say applying KCL at node C, I3 is equal to I4 plus I6 plus I6. 6. Okay, so we already have I3 there, which is 26 amperes. 26 amperes equal to I4, which is unknown, plus I6, which is 12 amperes. So therefore, I4 will be equal to 26 amperes minus 12 amperes, or I4 is equal to 14 amperes. Okay, and then applying KCL again at node B, we can see that the currents entering node B are I2, which is 22 amperes, and I4, which is 14 amperes, and that will be equal to the current leaving, which is I5. Okay, so therefore you can say that applying KCL at node B, current leaving is I5, so therefore we can say I5 is equal to currents entering the node B, which is I2 and I4. So I2 plus I4. So therefore I5 will be equal to I2, which is 22 amperes, and I4, which is 14 amperes. So 22 amperes plus 14 amperes. So therefore I5 will be equal to 36 amperes. Okay, so now we have I3, I4, and I5. I3, I4, and I5. So now I7. So I7 will be equal to, if we apply KCL at node D, I7 will be equal to I5 plus I6. So therefore, applying KCL at node D. So therefore, if we apply KCL at node D, I7 will be equal to I5 plus I6. So I7 will be equal to I5, which is 36 amperes, plus I6, which is equal to 12 amperes, plus 12 amperes. Okay, therefore I7 will be equal to 36 plus 12 will be 48 amperes. Okay. And finally, for current divider theorem. So we have the current divider theorem formula. Ix is equal to RT divided by Rx times IT. So Ix will be the current through resistor Rx, and RT is the equivalent resistance of the resistors in parallel, and IT is the total current. For example, for this circuit, we have the 3 resistors in parallel, which is the same as the resistors in example 1, and the total current, which is calculated in the example 1. So the total current will be 10.21, and then we have the 3 resistors, 7 ohms, 5 ohms, and 12 ohms respectively. So there's no source voltage given in the circuit, And we are asked to find the currents I1, I2, and I3 using the current divider theorem. So if we apply the current divider theorem to find I1, so in this example, if we are going to find I1, so X there is 1. So whatever current we're calculating, the subscript there is the value of X. So for example, so we're going to use the same 3 resistances in parallel as per the first example above. So, and then the total current is 10.21 amperes. But in this case, voltage source is not given. So we're asked to find the currents I1, I2, and I3 by current divider theorem. So because we're using the same example as above, we already computed the total resistance as 2.35 ohms. Okay, so let's just use that. So in order to find I1, so I1 will be equal to RT, which is 2.35 ohms, divided by Rx, which is in this instance, because we're trying to calculate the value of I1, so Rx is the R1, which is 7 ohms. 7 ohms. And then we multiply that by the total current IT times IT, which is 10.21 amperes. So I1 equals, so I1 there will be equal to 3.43 amperes. Okay, and then for I2 it will be RT, so 2.35 ohms divided by Rx, which will be R2, so 5 ohms, times IT, which is 10.21 amperes. Okay, so therefore our I2 will be equal to 4.8 amperes. Okay, and then finally for our I3, will be RT, which is 2.35 as well, 2.35 ohms again, divided by Rx, which is R3, 12 ohms, times 10.21, which is IT, 10.21 amperes. So that will be equal to 2 amperes. Okay, so that's how you find currents through resistors using current divider theorem. So that's it for our video for today. And if you like it, please feel free to share it. And please don't forget to subscribe to my channel. Thank you very much and God bless.